Hey everyone, we're going to try something a little different. Just ignore these boxes here. I'm just typing into a PDF publishing document so that I can edit, because this involves a lot of reading and writing and I want it to be clear. The document camera is great to use when I'm showing you how to use a calculator or have to write some things out. But on this one, I want you to really be able to read along with me. And I think it's not a very good document camera that I have access to. So here is Chapter 8, Statistics Collecting Data. So this actually will start on page 89 of your workbook. So we're in Chapter 8 here. I'll try to highlight some key points. You can just write up in a notebook if you want, or again, printing this and then writing directly into it. But do remember, I want any of the examples, so any of the stuff that I write out with you and you write as I'm going, or the classwork that we stop for. Both of those should be submitted for full points, about 80%. So like if it's 14 problems, take 14 times 0.8. And then you know how many problems you need to submit. There's always that 1 or 2 or 3, depending how many you have, that you might not be able to get in classwork. You should be able to get all the examples though. Statistics provides tools so that a person can react intelligently to information he or she hears and or reads. So it's one of the most important things to study. You may take a full course in statistics later on. That would be a really good idea. Here's some claims that we have. AT&T has the lowest drop calls. I think Verizon is pretty good. That's what I use. 4 out of 5 dentists recommend Dentine. That's just, some data that we've collected, or whoever did this. Almost 85% of lung cancers in men and 45% in women are tobacco related, and you can read through on your own the rest. Statistics is collecting, organizing, summarizing, and analyzing information so that intelligent conclusions are made. We're using data to draw conclusions or answer questions. We can display that data. Sometimes we just want to see what it looks like. Other times we want to make inferences and predictions. So these are the key things here. Populations and samples. We'll need to look at what's the difference between a population and a sample. So if we want to study the amount of money spent on textbooks by a typical first-year college student, our population might be all first-year students at a particular college. So you do need to say, if you're talking about the population, you want to try to definitely define that and stick to that. I'm going to pull down here. So the population is the group that the collective data is intended to describe. Sometimes we call it the target population, because in the event of a poorly designed study, the collective data may not be a good representation of the intended population. So sometimes we have issues there. A dentist really wants to see if 4 out of 5 dentists prefer Dentine gum over any other gum at his dental school. What would be the population? And on this one, it's asking about dentists. So I think you would have to say those dentists at his school would be the intended population. So he would need to survey all of them. The parameter is a collected value, average, or percentage that is obtained from the population. So you can see here, I'll just highlight population is the dentist at his dental school. That is what the answer is for that one. I will write the answers in blue there. The parameter would be the 4 out of 5. That is what we collected for the average or percentage or whatever you're finding out. The definition, a survey of an entire population, is called a census. You may have heard of census taking. That's kind of going on in the news now. That means they're really trying to get every person in the entire population. And that's really can be challenging. So what we most likely want to do, as you can see on page 90, is to get a sample, a smaller subset of the population. And when we calculate the average or percentage and so on and so forth of those things, other statistics might be like standard deviation and things like that, that is called a statistic. And from that, we can make inferences and predictions about the broader population. Okay, so now here are two examples that from that information that I just gave you, if you could try to figure those out, figure out what the average length of a trout in a lake, to figure out that dimension. The researchers catch 20 fish and measure them. What is the sample and what is the population? So go ahead and you can pause the video and write that out and then check what I type in. Example 8.3, a college reports that the average age of its students is 28 years old. Is this a statistic or a parameter? So that's, remember, a statistic goes along with a sample, and a parameter, we would call it that if we are collecting the data from the entire intended population. Remember, that's not everybody in the world, but it's like how it's defined. Okay, so the answers here, the sample is the 20 fish that are caught by researchers. I got a little typo there. And the population is all of the fish in the lake. For 8.3, this is a parameter since the college has access to the ages of all students. So this next section is about categorizing data. So in order to look at the data, either display it, crunch numbers on it, or any of that stuff, we want to figure out if it's categorical, or sometimes that's called qualitative data. So it's not measurable, but we can classify the objects under investigation into various categories. So it's different. So like a number on a jersey, for instance, would be categorical because it's not any kind of measurement like a height or things like that, but it's a number, but it's just labeling, like a name. The same thing, like names, eye color, all that kind of stuff is categorical. Quantitative data isn't just numbers like I used in the example before, because sometimes numbers are more just, they're not measurable, it's used for labeling purposes and putting people into categories. But quantitative data are responses that are numerical and meaningful arithmetic calculations can be applied. Okay, so you can measure it, you can crunch numbers with it, and so on. So here's a couple of examples. Example 8.4. So I want you to take a look at that. I'll talk about a couple in a minute, but there's a whole bunch here. So for example, temperature, you can crunch numbers with that. You can add temperatures together and it makes sense in a meaningful way. So that would be quantitative. Where, let's see, zip code, for instance, that is just labeling where you live. It's putting people into categories. So that would be categorical or qualitative. So I'm going to use categorical, the word categorical, because I think that's easier to distinguish when you're writing it down, especially if people are using script. And you can abbreviate CAT if you want, and then quant, you could abbreviate for quantitative. But if you're just abbreviating qual and quant, they kind of can look the same sometimes, so just be a little bit careful with that. So stop the video and go ahead and fill these in, and I'm going to go ahead and do that as well. Okay, so as you can see, I put your answers here in blue, and you can take a look and see how you match up for that, and just let me know if you have any questions. All right, now we're moving on to page 92. Sampling methods is section 8.3. I think I'm going to stop here and split up this chapter into a couple of videos just so they don't get too long for loading up and things. See,